got about 1 amp DC amp coming from the process where we remove the solid state DC supply to the field, and we are using a circuit from the resonance itself to feed the field, a self-feedback loop scheme. The self-feedback loop scheme is very cantankerous. Sometimes it runs out of control. But here we've shown a 12-volt operation. Two secondaries. There's two 12-pound 23-gauge wire secondaries in series over the poles of the 666 machine, and we have a gate circuit between them. This, incomprehensibly, the position of the secondaries in space will govern the voltage of the generator. And right now, if we take that coil above space, that wooden dowel, put it back on the pole, it will shut the whole process down. Okay, well, we're looking at what we're functioning at right now. Looks like about 8.8, 10.4, 9.9, or 10.6, pretty fluctuating 3 stator voltages. And 2.5, 2.1, and 1.3 amps on the phases. That's just for reference, and now what we're going to do is get a shot of putting this coil back down the self-regenerative system. Try to get a shot of the bulb in there, which seems possible. Now we're going to go down in there and shut the process off inductively in this magnetic chain reaction. Now we see that these outer secondary coils function as a kind of midpoint grid in a magnetic system, where the placement of these coils chokes off the current to the field self-feedback circuit. So we'll see up here now, we only have 3.2, 3.1, and 3 volts, and half an amp, 0.3 of an amp, 0.5 of an amp on the phases. So these outer coils are controlling the process. Now we'll go over here and briefly describe the self-feedback process. The field is accomplished by the intervening gate coils. So much stick somewhere. Like there's one of them. That's one of the gate coils. That's between the primary 3-layer system and the secondary high multi-turn, and a single spiral omega cables in between them. Same thing goes for the back coil. And we got a little thing here to show how these spiral secondaries are situated. Yeah, that's right there. So we got secondaries over pole number 2, pole number 1, and underneath pole number 3. Now we go over here, we got voltage meters on all that too. We call this a communist electrical circuit. It's a forced oscillation. All three of these coils, this one, and the one underneath, are all in series. We have voltage meters on each one of them. And because they're all in series, the current that they produce from their source is all in phase. It's one phase. Everything is collectivized. That's what we route to a full wave rectification system. This shows the voltages on the system. We're presently procuring 3.7 volts, and we're sending out, as we earlier mentioned, a fifth of an amp into the field. All ballasted and controlled by these secondaries. Now at any point in time then, we can remove the self-feedback loop and see what the operation of the machine is with no field input whatsoever. Do that now. And that's not going to tell you much, but now we got 2.5 volts open circuit available to go to field. Now we're going to remove the back secondaries completely so that we can see the unfiltered amount of current or voltages made on the communist electrical circuit. Okay, as we can see then, we removed the secondaries. That gate circuit, its voltage went up, and we're now able to provide 3 volts to the field. If we now just provided 3 volts to the field and hooked everything up, it would go overload. Because of the fact that the primaries on the second cycle of magnetism will be picking up more voltage and in turn self-feeding back more voltage to the field, going on and on, cycle after cycle, until overload operation of the alternator will result. Okay, did we explain this a little better? Thank you.